My name is Madison, and right now I'm in one of Wheaton's Fab Labs. Today I'll be giving you an introduction to the Axiom CNC router. CNC cutting is a subtractive manufacturing process. You may have used a 3D printer before, which is an additive manufacturing process whereby the printer builds an object up layer by layer. A CNC router takes away material layer by layer. CNC, which stands for Computer Numerical Control, refers to its abilities to run off computer design programs, called Computer-Aided Design, or CAD, and Computer-Aided Manufacturing, CAM. Today we will learn how to use one type of software, but no, there are many options. Let's get started. Let's first go over some safety protocols. When you enter the shop, you must be wearing closed-toed shoes. You must also have easy access to safety goggles, like these, and to ear protection, like this. In addition, anything that is loosely hanging from your body, such as lanyards, jewelry, or long hair, needs to be securely attached to your person. Now let's go over some basic components of the Axiom CNC router. This is the machine bed. This is where you'll securely attach your material that you are cutting. This is the controller. This is how you will start and stop your CNC jobs, and this is also how you'll manipulate the X, Y, and Z axes. This is the gantry. In very simple terms, the gantry is what allows our tool to move around the machine bed. This is the dust shoe. Pull down to remove the dust shoe. Now we can see our collet nut and our bit. This is how we turn the CNC on and off. And over here is the dust collection system. This is how we turn the dust collection system on and off. Before we can begin a project, we need to create a design. You can use a myriad of 3D modeling softwares to create a file, but in this video, I will show you how to use VCarve. The software is not free and is currently installed on the computer in Lab 213. Let's create a new file. Remember to measure the width, height, and thickness of your material. Now we'll go through a few different shapes. You can click on the circle tool and make a few circles on the work plane. You'll need to click on the transform mode to edit objects. If you move your shape to the middle of your work plane, it should lock into place. Now let's create another circle. There are other options such as text, there are different line tools, and these are all good to explore. Now click on the Toolpaths tab. We will select the outer circle and we will be making a profile cut. All of these different options are important to go through. Let's remember that the start depth is the top of our material because that's where we put the Z0. If we want the material to cut all the way through, we need to put the depth of the material in cut depth. Now select your tool. There are a variety of tools to use, and there are different tools that are better for different projects. We will not go through that right now. You also need to select where you want the machine to cut. It's important to add tabs to any profile cut that is cutting all the way through the material. This secures the material and decreases the likelihood that it will rattle or come away from the machine bed when you're cutting. Ramps also help to maintain the integrity of your bits. Make sure to name your file something that you will remember and include the bit that you will be using in your file name. Click on Calculate once you have decided a good name for your toolpath. Now you will see that we are in 3D view. We can slow down the speed and preview what our selected toolpath will look like. Always preview your selected toolpaths to see if they're doing what you expect them to do. Here you can see the 4 tabs that we inserted. Close this. Let's go back to 2D view. And let's select the inner circle. We're going to be using a pocket toolpath for the inner circle. So we don't actually want this toolpath to cut all the way through. Let's just cut about 0.40 inches into the material. We are going to be using the same bit. Again, remember to name this toolpath something different from the original toolpath. This is a pocket cut, so we can leave pocket and then add down cut since we're using a down cut bit. Calculate. Now we'll slow down the speed again and we'll preview this toolpath specifically. This looks good. Now remember to save each individual toolpath onto the USB drive and take it into the shop where you'll insert it into the controller. The following steps should be performed at every startup. When turning on the machine, a message will appear on the handheld controller giving you the option to perform an all-access home. Push the OK Origin button to home. There are 3 relevant components that we need to discuss. This is the bit, collet, and collet nut. The bit is held in place by friction. As you tighten the collet nut, the collet tightens around the shaft of the bit. This means the contact between these two need to be smooth and uninterrupted. Every time you remove a bit, you remove all components and blow dust out. Now I'll demonstrate how to insert the bit. Put the collet in the collet nut. You should hear a pop. They should be evenly aligned, and the collet should spin freely within the collet nut, like so. This is the bit. Do you see the smooth, uninterrupted part above the fluting? 80% of this should be in the collet. This is how you would insert the bit into the collet once it's on the machine. You can see how only 20% is showing of the uninterrupted smooth portion of the bit. Now we will insert the collet inside of the collet nut onto the CNC. Use just your fingers to tighten this. Now insert the bit like we discussed. Only 20% of the smooth portion above the fluting should be visible. Now use the wrenches to tighten all the way. Do not over tighten. This part can be tricky. Now we will create an origin. To set the Z-axis origin, find the blue focusing tool under the CNC. Plug in the cord at the back left of the CNC. Then use the handheld controller to center the tool over the blue object. Using the handheld controller, then push tool set. The bit will lower to touch the blue piece and should lift back up. This sets your Z-axis. Now we need to set the XY origin. Again, this should match the toolpaths that you created in your CAD software. Use the handheld controller and toggle until you get to the desired XY location. Then click XY0.